scale a little bit, but it actually was right in the middle, so I changed it to that small so it widened it out a little. Okay, let's see how we did. First of all, I would love for you to have a basic x to the fourth shape. So I would look at your graph and say, does this person at least know x to the fourth should go up and up on the outside? I did make this tailor-made to factor pretty well, so it seems like you should also know the roots are 0, 1, and -1. Yeah? All right. All that's great. Seems to indicate a certain type of graph, and now let's go into the calculus. F prime, I would probably give 1 point. This probably would end up being a 6 to 8 point problem. 1 point for knowing the derivative is 4 cubed minus 2x. Another couple points for finding the zeros of the derivative. Did you take a 2x out, leaving you with 2x squared minus 1 in? And you get zeros at x equals 0 and positive or negative square root 1/2. Yeah? Okay, that would probably be 2 points, so right now I would say you got 1 point there, 1 point for the derivative, 2 points for the critical numbers. And now let's sign test this bad boy. Oh. These numbers were not wonderful to sign test. When I go to sign test this, I don't get too into what that number is. I just think, well, let's go something negatively large, like -10. That's negative. This would be positive, yeah? So it seems like because f prime is negative there, f is decreasing, then flat. This is kind of a funky territory here. I wasn't sure, but I thought, let me go with just a really small negative number. I didn't try and figure out a number. I just said, give me a small negative in there. So a small negative here would still be negative, but a small negative here means close to 0, so that would start to approach negative. So I feel like that is positive. So the function, when increasing, 0 then, small positive is positive, negative, negative, so decreasing, and then huge positive is positive, positive, so increasing. So did you get a sign test looking something like that? Yes?
Yep.
Cool. So I did a scale of a quarter, so it was really spread out, and I know I have zeros at -1, 0, and 1, and shoot, I don't know what the square root of 1/2 is. That's the square root of 0.5. I imagine that would be about 0.7. 0.7 times itself is 0.49, so I imagine that's probably pretty close to 0.7. You with me? You don't need to, as long as you have somewhere in here a min. Is there symmetry to this graph? What do you call a function that's symmetric about the y-axis? Like x squared, or x to the 4th, or x to the 6th, or something with all even powers. We should call it even, an even function. Is this an even function? Yes. Yeah, x to the 4th and x squared. They're both even powers. So combination is still an even power. So this is an even function. It looks like that. And now, justify the extrema with the first derivative test. The conclusions will probably be a little more, probably 2 points for each conclusion. So give me the minimum conclusions. Can I just say minimum at? You cannot, okay? And any one problem you have, generally, by the time you get there, you'll have at least 4 different things varying. F, F prime, F double, and X. So just say minimum at, what has a minimum? F, F prime, F double, X, what? So if you just started your sentence saying minimum, no, not good. F has a, or has minimums, can say them together. At x equal positive or negative square root of 1/2 because y. F prime changes from negative to positive. Okay? Okie dokie. 2 points for the maximum conclusion. F has a max at x equal 0 because F prime changes, so it goes, if you like, from positive to negative. How'd you do? Success? Okay? If not, then you have another chance at redemption. Number 6. You have g of x. Right away you should say, hey, self, pay attention. It's g, not f. If you start seeing f and f prime, will you be losing points?
Yes.
Yes, you will. Okay, so be careful. Use the function name you're given. G, you're talking g here. It's a negative x to the 4th. Could you have a graph of negative x to the 4th with one horizontal tangent? What would that graph look like? First of all, negative x to the 4th. Does it go up and up, down and down, or up and down? Down and down. If it has one horizontal tangent, then it could do, I don't care what craziness, but it can only have one place it goes flat, yeah? Could even be a parabola looking shape. How would you have two horizontal tangents? Think of how you could draw it with two flat spots. Try that on your own. Okay? It has two flat spots. I got one there. When I go to flatten out here, can I turn up? No, because that means I'll have to have another or three flat spots. So on one of them, you can't turn back up. It has to be flat, then back down. What about this person? Flat, like that. Does that work? Yeah, that's good. Two flat spots. All right. What about three flat spots? Draw one with three flat spots. Heading down and down on the outsides. So anything with three horizontal tangents going down on both sides should look like that, yay? All right, now, which of these shapes it could be depends on what the derivative looks like. What will the derivative come out to be when you take g prime? What's g prime, please? Negative x to the third.
Plus 2x squared.
Plus 2x squared.
Minus x.
Minus x. Plus 2. Now, flat spots come from where the derivative is 0. A cube is what the derivative is. Is it possible that this derivative cube has no real solutions? Is it possible to get a cube with no real solution?
No.
It is not possible. Every cube or odd power has at least one real solution. Is it possible to get a cube with one real solution and two imaginary? Yeah, which of the graphs would that indicate? First one, second one, or third one has one real 0.
First one.
The first one. This would be the case that happens if this derivative has one real 0. Is it possible that a cube has two real zeros, maybe one of them being a double root? Is that possible?
No.
You could have, isn't it possible that you have something like x squared times x minus 1? Isn't that possible that it has two roots and one of them is a 0 that's doubled? So a cube could have two real zeros, and that would be case 2. And it's possible that a cube could have three real zeros, that would be case 3. What I want you to do is solve g prime and figure out which of the three cases it is. One flat spot, two flat spots, or three flat spots. many real zeros are you getting? It is 1, yes, because the other one is imaginary roots. There's a plus or minus I case, so there's 1 root. The last thing you have to do then is do the first derivative test to say what's going on there, extrema-wise. Kind of know from all the pictures it's got to be a max, yeah, but do the derivative test to verify. Okay, speak your conclusion to me, please. G, not F. Awesome. G has a
Max.
max at
X equals 2.
because
G prime changes from positive to negative.
you. All right, cool. So, how would you do on a question like that on the test? Would you kill it?
I think so.
Okay, excellent. Not on the test, but something I want to review is number 2. Say you were absent, say your buddy next to you was absent on Friday and they missed the chain rule. First thing you tell them is when to use the chain rule. You use the chain rule when?
Function such a function.
When you're trying to take the derivative of a function within a function, a composite function. And what is the chain rule? How do you take the derivative when you have a function within a function? Take the derivative of the
First.
outside. In this case, what's the outside? E to the x. So you take the derivative of e to the x, which is still e to the x, but the inside stays
The same.
the same. So it's the derivative of the outside with the inside the same, which means e to the square root of x. Then multiply that by
The derivative of the
the
inside.
derivative of the inside. What is the derivative of square root of x?
1 over 2 square root of x.
1 over 2 square roots of x. And what's the derivative of 3? 0, so you can leave that off. That's the chain rule. You follow me?
Yes.
Okay. Now, our book doesn't go this way very much, but it is pretty common in at least the Rogowski book, which is what they use at mine. A lot of calc books do practice on the whole chain rule kind of thing in its original form. So imagine you had 3 functions. Y is a function of u is a function of v, and v is a function of x. If I wanted to see how y changes, how does y change as x changes? That's really what this means. dy dx have meaning. How does y change as x changes? Well, there's a bit of a domino effect. Don't you agree that when x changes, it changes v?
Yeah.
And then when v changes, it changes u. And when u changes, it changes y. So y is indirectly related to x. The question is then how? Well, that's the chain rule, all right? So start by saying, what is dy du? How does y change with u? To u, okay? Du dv, how does u change with v? E to the v. And then how does v change with x? Or what is dv dx?
Cosine x.
Cosine of x. All right, now that's great. That is dy dx. This is dy dx we just found here, because by doing that, du's cancel, dv's cancel, and I have y changing with x. That's cool. But it should be in terms of x only. So now, get it in terms of x is the next and last thing to do. So, let's call u what? U is equivalent to e to the v. And e to the v I'll leave alone. All right. So at least now I've replaced u and it's all just v and x. Now what can I do?
Change v's.
Change v's to sine x. So our final answer is 2e to the sine of x times e to the
Sine x.
times.
Cosine x.
That's you. They can scared the life out of
Can
me.
you make that 3?
Only if you want to break math.
You can't wait.
So you can combine, okay, you can combine, and I'm glad you asked, because multiple choices, you often would see that. Do those add to 3 or multiply to 2e sine squared? I'm so glad you asked, because on the multiple choice, they would often, the derivative goes great, but then the algebra kills you. Some people would say, is it 3e to the sine of x, cosine of x, and that's part A. Part B is it 2e to the sine squared of x, cosine of x? So that's C. B rather. C is it 2e to the 2 sine of x, cosine of x? Or D, none of the above. Which is it, A, B, or C?
B.
It is time to review exponent rules. If I have something with the same base, don't you agree that I'm saying how many do I have altogether? So the rule is that I add the exponents. So 2e to the 2 sine of x. It is C. Okay? Okay. Yeah, good call, Colin. All right, let's go to box 23, which I believe is on the back side. We're going to do little bits and pieces to this, but you'll see that all that physics knowledge you work so hard to acquire, you have a major advantage to other people throughout the country because you have received top-flight physics instruction. And this part will not be the hard part for you, it'll actually be the easy part for you. You just have to understand the calculus physics relationships. So, here we go. If P is position, then P prime, now think of that as dp dt, change in position with time. What is that? What do you call it when you change position over time?
Displacement.
Velocity. I should have said a rate at which you're changing position over time. It is the velocity. So the derivative of position is velocity. The derivative of position is velocity. All right. What about then the second derivative? Well, that's the change in velocity. That's dv dt. If I talk about the rate at which you're changing velocity with time, that's acceleration. Acceleration. Acceleration is the derivative of the velocity, or the second derivative of the position. What is the absolute value of velocity? It is speed, how fast you're going without respect to sign, or take the sign component out of it. Just talk magnitude of velocity. Now, slope of a position curve. Well, that's derivative of position. And derivative of position is
Velocity.
velocity. So if I give you a velocity curve and I say, hey, what is the slope at time 2? You're also finding the velocity at that time. All right. Slope of a velocity curve. Well, that's the derivative of velocity, and that is
Acceleration.
acceleration. All right. Now, this is an idea we haven't talked about, so I'm just kind of gradually introducing. Area under a curve. Now, in calculus, it's pretty common that rather than just graph something, you actually graph it and look at what the area under that curve means. It has huge meaning. So imagine if I just, would you draw yourself just a little doodle? If I said if velocity in meters per second is always 5 meters, you with me?
Yeah.
And the time frame is only over 4 seconds. Then when I do the area there, base times height, what's the base with unit?
4 seconds.
4 seconds. And what's the height of the rectangle with unit? 5 meters per second. Well, the seconds drop away, and the area under the curve, or the area of that rectangle, is 20 meters. What does that mean? If you go 5 meters per second for 4 seconds, that 20 meters is your displacement. Area under a positive velocity curve is displacement, and if it's positive, it's also distance. If the velocity is positive, because if your velocity is positive, you're only moving one direction anyway, and how far you go and how far you're displaced. Okay, now they're not always going to be the same this year, but in this case, it's a simple case, they are the same. All right, now then, let's play around with a little case here. I'm giving you this crazy piecewise function, and it's not too bad, actually. And we're going to graph velocity over time. All right, so the first branch of the piecewise is to graph v equals t from time 0 to time 3. Use a scale of 1 for both. Okay? So at time 0, where does that piece start? 0. And at time 3, where does it end?
3.
3. And in between, what's the shape of the graph?
A
A line with a slope of 1. Yeah? All right. From time 3 to time 2, let's get the starting point. At time 3, where does the second graph start? And you put in time 3, negative 3 plus 6 is?
3.
3. So it starts at 3, 3, which is to say it's picking up where the other graph left. That's good, because velocity needs to be continuous. What about at time 6? Where does it end? At time 6, velocity is? 0. And what's the slope in between?
-1.
Negative 1. So we're looking at a second branch that looks like that. And the last, at time 6, where does that third branch start? 0. 1/3, 1/2 of 6 is 2. Nope, 3 minus 3 is 0. I agree. Where does it end? 1. So it goes to 8, 1. And the slope is up 1 over 2, yay?
Okay.
All right, so there's the velocity graph. We'll go to the question in a second, but please explain to me from time 0 to time 3. Let's say it's a person's distance in a car moving right, left. What's going on from time 0 to time 3? The person is moving right or left? Right, at a constant rate or at an increasing rate? Is the velocity constant here, or is the velocity growing? It's growing. The velocity is growing. It was at a stop at time 0, and he moved right until time 3. At time 3, is he not moving right anymore? Is he starting to move left, or is he still moving right? Still moving right, okay. He continues to move right, but his rate is decreasing in time till time 6, when at time 6 he is stopped, momentarily at rest. And then after time 6, it is, from 6 to 8 is moving right again, but at a slower rate, right? Okay, so if you were to do this, you could say he was always moving right, and he would be going faster and faster until time 3. So something like this. 1, 2, 3, and then starts to slow down, but I ran out of room. From 4, 5, and 6 until I stopped at 6, and then at time 6, I started moving again, but a little slower. You with me? Okay, cool. All right, then, acceleration at time 7. What the heck? Acceleration at time 7 is the derivative of velocity, which is the slope of the velocity graph at 7. And so what is acceleration at time 7? 1/2, right? Here is time 7, and the slope of that line is 1/2. Follow me?
Yes.
Okay? The total distance traveled. Think of this as, I'm going to give units here. I'm going to say this is meters per second, and this is seconds. Total distance traveled, then, I need to find, this is what makes calculus so beautiful. His rate is actually changing. It's not like up here where he said, oh, it's always 5 meters per second for 4 seconds. It's more complicated than that. His rate is actually constantly changing, and yet you can find distance by saying, if you take all of these velocities, all these different velocities, times that time, it really just is the area. So how much area in the first triangle? 9 over 2, okay? That is to say, in time, in that first 3 seconds, he went 4.5 units. from time 3 to time 6, he was still moving light, but slowing down the whole time. How far did he move in those next 3 seconds? Again, 9/2 or 4.5 units. And then, how about that last triangle? What was his rate times time then, which represents the area under the triangle? 1 unit, 1 times 2 divided by 2 is 1. So how far did the person travel altogether? 10 meters, or in essence, at 8 seconds, he was 10 meters from his starting spot. It's also his displacement, yeah? Okay, cool. Try this one on your own or with your math amigos. This is on the front. I think it's somewhere in the upper half of the front. Yeah, that's the one. Making sure you're on the right track. How do you imply, or what's implied by not moving? S equals 0, doesn't that mean its position is 0? Velocity is 0. If it's not moving, then the velocity is 0. If the velocity is 0, that means, calculus-wise, S prime is 0. So you should be finding where the derivative of position is 0, because that means its velocity is 0. Again, before you do too much in the wrong direction, let's make sure your derivative is correct. 2t minus, what's the derivative of sine t squared? Cosine of t squared times 2t, chain rule. Did you do the chain rule correctly? Yep. You're getting there. Now, can you do the pre-calculus? Can you solve that equation without error? How would you solve that? Factor out of 2t, leaving you with 1 minus cosine t squared. Set 2t equal to 0, or 1 minus cosine of t squared equal to 0, yay? Is t equal to 0 your solution? No, it says find the first time greater than 0. And 0 is not greater than 0, so that, while velocity is 0 there, it's not a solution. So I guess you have to solve the other one. Cosine t squared is 1, right? Which means t squared needs to be 0 or pi or not pi? 2 pi or 4 pi, etc. And so t is the square root of 2 as the first time it happens. Square root of 2 pi is the solution. Okay? How'd you do there? Did you win?
No.
All right. Now this is very common in the AP test. You get these crazy, funky answers. You think, what the fuck? Square root of 2 pi? What is it? It happens. It happens. Things are ugly. Life is ugly. Get used to it. Okay? All right. Let's go to homework, please. Did you get out your homework from Friday? We got a lot of toughies done. All right. I did absolutely no simplifying of my derivatives. So, in terms of checking the work, I don't know if you simplified or not, but make sure you have labels here. I absolutely am going bonkers just looking at floating expressions with no label. So if you don't have labels, please get out a colored pen. If you want to make corrections, do it in ink. Okay? Put a freaking label on your work, people. Please, stop just giving me floating nonsense. H prime is 1/2 of x plus sine of x to the negative 1/2 times the inside derivative 1 plus cosine. Number 2, the outside power is, or the outside function is blank to the 3/2. So the derivative of the outside is 3/2. Inside stays the same to the 1/2. The inside then requires a derivative. Look at your work on the inside derivative. Did you use the product rule for the inside derivative? That's pretty common that you will see a function, two rules together, chain rule with product rule, or chain rule with quotient rule, which you haven't learned yet. Okay, number 3. The outside is the sine function, so the derivative of the outside is cosine with the inside the same, times the derivative of the inside is 15x to the 4th. 4 was a tough one. I beg you, write yourself a note if you missed 4. Please do a rewrite step first. It helps if you write p of x as 3 times x plus log of x to the negative first power, so that then it's clear the outside function is the to the negative first thing. So the derivative is negative 3, inside stays the same to the negative 2 when you drop the power by 1. Then the derivative of the inside is 1 plus 1 over x. I bet I got a lot of people with that one. Okay. The next one also is a rewrite step. It definitely helps if you rewrite that as sine is all squared. Then the derivative of the outside is 2 comes down, drop it to the first, and then the inside stays the same as sine, but then times the derivative of the inside is cosine. Okay? What if you saw a different answer there? What other answer might you see in multiple choices? Yeah, you could say sine of 2 theta. There's expectation of some basic identities there. That might be a choice. All right. Number 6, x prime or dx dt, given some kind of label, is the derivative of the outside, which is the e stays the same, inside stays the same, but then the derivative of the inside is 1 over 2t. 7, this is an interesting one. Log is the outside, so the derivative of the outside is 1 over, with the inside the same, so that's 1 over 2x. Times the derivative of the inside is 2. That gives you a derivative of 1 over x, yeah? It's pretty common in log problems. They'll give you funky choices. So that actually makes sense. If you think of log rules, what's log of 2x the same as? Log of 2. Isn't that log of 2 plus the log of x?
Yes.
And if you take the log of 2, that's 0 because it's constant, and the log of x is 1 over x. So that's logical. 8, dr d theta, or r prime if you like, is negative sine of 3 theta times the derivative of the inside, which is 3. And 9, it's your call. Some people broke this up first. They did a rewrite step and said, I'm going to take it as root 2 and t separately. That's fine. You could leave the 2t inside. Either way, you should get something like this if it was simplified, because there are 2's that go away. Okay, let's go on to the table. I got 1, -6, and -23. I'll be happy to go back over questions on these. Just hang on, we're gonna get you answers. 1, -6, and -23. Write it in ink if you missed it.
Wait, whoa.
1, -6, and -23.
I think we're
Okay. The graphing ones are -1/3 and -2/3. How'd those go?
yeah.
Muy bien. Okay. 15. The conclusion. This is obviously nowhere close to all the work I did, but the conclusion was f is increasing on -1/2 to infinity because f prime was positive. 16. My conclusion was h has a horizontal tangent at pi/2 and 3pi/2 because h prime was 0 there. We had to focus where the top was 0, not the bottom of the fraction. And then finally, the tangent line was y plus 1/2 equals -√3/2 x minus pi/6. All right, what would you like to talk about in more detail?
Number 15.
15, what else did you say, 1?
That one.
This one, okay. 15 and 17 and 9. 17, I'm going to do 17 first if you don't mind because it's here already. 17, 15, and 9. Okay, cool. Here we go. Make corrections, preferably in ink. And it goes a little something like this. I would love for you to demonstrate that on the test on Wednesday you could find an equation of a tangent line. So, the first part is finding a point. The point is when x equals pi/6, we need the y that goes with it. That you just plug into the function itself, no derivative yet. And that's no small amount of trig you got to do there. Negative sign of -pi/6. Negative pi/6 is this guy. And I get that the sign of that is -1/2. The negative of that then is, so that should be positive, shouldn't it? Or should this be -1 then?
No.
Because it's y minus y1, yeah?
It's not negative.
Oh,
It's
this is positive. Oh, sorry, I copied it down there. My bad. So it's -1. Yeah. Are we cool? Are we good? Okay, so the point is done. Pi/6 for x, -1/2 for y. Now the slope, please communicate that you're saying, hey, I'm taking the derivative at pi/6. Person reading this, what is the derivative of sine of -x? Now that is chain rule. What's the derivative of the outside? Cosine with the inside the same, but what's the derivative of the inside? What's the derivative of -x? -1. I know it's subtle, but there is a chain rule component to that. At pi/6 is negative cosine of -pi/6. And here's -pi/6. What is the cosine of such an angle? It's √3/2, and then stick the negative on after. So the slope should be -√3/2. Are we cool? Okie dokie. And then finally point slope form. Y minus y1 equals m times x minus x1. For this problem then is y minus -1/2, so plus. Slope is -√3/2, and in parentheses x minus pi/6. You do not have to put in slope-intercept form. In fact, please don't. You good? Okay, 15. Question on 15 still.
Yep.
Cool. All right. Find where a function is increasing. Increasing implies the first thing you have to do is make the calculus connection. Increasing is where the derivative is positive, yeah? I can't find where the derivative is positive until I first find the derivative and then find the 0. So that's the order. First find the derivative. By chain rule, you have a function within a function. So the derivative of the outside is e with the inside the same times the derivative of the inside. It's the derivative of x squared plus x. 2x plus 3. Okay, we want to find where this is 0 because that's the dividing line between positive and negative. Can e to any power ever be 0? No, that's never equal to 0. So I just need to focus on the solution to the linear component, which is negative 1/2. Then I would say something like test before and after. Before, like a negative a billion. The derivative is always positive, negative, so negative, implying decreasing. And after, maybe at 0, positive, positive, so increasing. Therefore, we conclude f is increasing from negative 1/2 forever after because the derivative is constant. Allah?
Yep.
Cool. And 9. Question on 9.
Yes.
Okie dokie. So, here we go. This looks like the derivative of a difference. Do I need to do some funky rule, or can I just say, take the derivative, take the derivative? Yeah, sums and difference, you can just take the derivative, take the derivative. What about the 5? What do I do with it? So it's just applied to the f only. So it's 5 times f prime, and then g prime does not hit the 5. It's just its own floating g prime. So when you go to apply that 5, only apply it to the derivative value, not the g, the f derivative value, not the g derivative value. So that might be the problem. Maybe you applied it to both. 5 times f prime only at 1 is 5 times negative 1/3. And subtract g prime at 1 is negative 8/3. That's negative 5/3 plus 8/3, and that's where we're getting 1. So was the question, was the problem that you distributed the 5
I
whole?
did that f x and g x instead of f prime x and
Oh, gotcha.
that is what I did.
Okay. Okay, good to know where you guys are making a mistake. Cool. All right. Anything else on this? Sounds like it went pretty well. Good. Okie dokie. If you have any questions on